Dear students, today we'll discuss about valence electrons and valency. First of all, we have to know what is valence electron. To know valence electron, we have to write the electronic configuration of an element. Sodium is atom number 11. If we write the electronic configuration of sodium, 1s2, 2s2, 2p6, 3s1. Here, the outermost electron of sodium is 1. The outermost electron of an element is called valence electrons. Here, outermost electron of sodium is only 1, so the valence electron number is 1. Again, chlorine, atom number 17, 1s2, 2s2, 2p6, 3s2, 3p, 10, 11, 12 and 5, total 17. So here outermost electron of principal energy level is 5 and 2, 7. So valence electron of chlorine is 7. Again, if we write the electric configuration of aluminium, the atom number of aluminium is 13. So 1 is 2, 2 is 2, 2p6, 10, then 3s2, 12 and 3p1. Here outermost principal energy level 3 and 3. Here in S there is 2 electron, in P there is 1 electron. Total 2 and 1, 3. So the valence electron number of aluminium is 3. Look, I draw the diagram of two elements. Here sodium. This is the electronic diagram of sodium. Here in first cell there is 2 electron, and the second cell there is 8 electron, and the outermost cell of the sodium there is only 1 electron. So from this figure we can say outermost electron of sodium is 1, and this will be the valence electron of sodium. So sodium, its valence electron number only 1. Again, look here, chlorine. This is the diagram of electron configuration of chlorine. Here in first cell there is 2 electron. This is the first cell, and in the second cell there is 8 electron, and the third cell there is 7 electron. So like this type of diagram, electronic diagram, we can say the outermost electron of chlorine is 7. So 7 is the valence electron of chlorine. Now we know the valency. What is valency? We know different kind of elements connect with different kinds of another elements or atoms, and they form bond to make the molecule. Look here, H2O. This is the molecule of water. Here, one oxygen connected with 2 hydrogen. Here, oxygen have 2 hands and hydrogen have only 1 hand. Why? Because simply we use this type of thing. Valency of oxygen is 2 and the valency of hydrogen is 1. Okay, another compound, sodium chloride. Here the valency of sodium is 1 and the valency of chlorine is 1. Why? Because in this compound sodium donate 1 electron to chlorine and chlorine receive that electron. So here this bond formed by the donation and acceptation of electron. So 1 electron donated by the sodium, that's why the valency of sodium is 1. Here 1 electron accepted by the chlorine, so the valency of chlorine is 1. And in this compound H2O molecule there is oxygen connected with 2 hydrogen atom. So the valency of oxygen is 2 and 1 hydrogen connect with 1 hand of oxygen. That's why the valency of hydrogen is 1. So now we know the valency of elements Now I have discussed some way to know the valency of the elements. Look here. First we will know the valency of the nonmetals. How to get the valency of nonmetals? First, hydrogen. 1s1. This is the electronic configuration of hydrogen. For the non-metals, the outermost energy level, and there will be some odd electron. The number of odd electron will be the valency. So here hydrogen only one electron of its outermost shell. So this is the valence electron of hydrogen. For the oxygen, 2, 1s2, no, 8, 1s2, 2s2, 2p4. This is the electronic configuration of oxygen. Here the outermost energy level, there is total 6 electrons. So what will be the valency? So valence into number 6. Now we will know the another way. We have to write this electronic configuration this way: 2s2, and you have to divide the p orbital, 2px, 2py, 2pz. That means p orbital we can divide 3 way, 3 types: px, py, and pz. And every shell there will be 2 electrons. Highest electron capacity 2. So here is 4 electrons. So we have to give the electron like this way: 1, 1, 1, and the rest electron will be here. So it will be 2, 1, 1. Okay. So in this 2px there is 2 electron, and the 2py there is 1 electron, and 2pz there is 1 electron. So how many odd electron in this electronic configuration? 2. That's why the valency of oxygen is 2. Now we'll discuss the other metal for phosphorus. Its electronic configuration: 1s2, 2s2, 2p6, 3s2, then 3p. We need to count 2 and 2, 4 and 6, 10, 11, 12, and we need another 3 electrons. So it will be here. So we need to write this: 1s2, 2s2, 2p6, 3s2, 3px, 3py, 3pz. So if we separate this electron, then it will be 1, 1, 1. So how many odd electron here? Here is 3 odd electron. Of the outermost energy level, there is 3 electron. That's why the valency of the phosphorus is 3. But we know phosphorus have 2 valency, 3 and 5. So how to get the valency? We can write this electrically another way. We know for the electronic configuration of phosphorus there is 3d shell, but that is empty. So from here 1 electron, if write this way, 3d 0, we have 3d shell. So this electron will be there. If this electron transferred there, then it will be phosphorus 15, and we have to use this star, that is excited state. Then 1 electron will transfer from 3s to 3d. Look this: 2s2, 2p6, 3s1, 3px1, 3py1, 3pz1, and 3d1. Now look, here is 1, 2, 3, 4, 5. Total 5 odd electron. So 5 odd electron, and the valency is 5. Like this way, we can get the valency of a single element in phosphorus 3 and 5. Now we will know the valency of some metals. This is for the non-metals. Like this way, we can know the non-metal elements valency. Okay. So while we will write the electronic configuration, then we have to find out the odd electron, then the outermost shell, their number of the odd electron will be the valency. Now for the metals. And for the metals, the way to get the valency is very simple. The number of outermost electrons will be the valency for the metals. Look, sodium, atom number 11. So electronic configuration 1s2, 2s2, 2p6 and 3s1. So in the outermost shell there is 1 electron, so the valency of sodium is 1. Same way for the aluminium, and we got 13, 1s2, 2s2, 2p6, 3s2 and 3p 10, 11, 12, 13. So in the outermost shell there is 3 electrons. So the valency of the aluminium is 3. For another metal, maybe magnesium, the atomic number of magnesium 12. So 1s2, 2s2, 2p6, 3s2 up to here 10 and 12. So in the outermost shell there is 2 electrons. So the valency of the magnesium is 2. So like this way, the number of outermost electron of any metal, the total number of electrons or outermost level, that means valence electron will be the valency of that electron. So in this way we can get the valence electrons and the valency. Thank you. Up to here. I love this.